Okay, so I thought I'd try and work through this quickly and then you can play it back if there's any issue with it. So the question was a small track, radius 44 meters, banked at 20 degrees, frictional force is equal to the weight. Okay, so diagrams always help. And the better you can draw the diagram, the more obvious the answers usually become. So we have the banked track. We know this angle is 20 degrees. I'm going to draw the car a little bit smaller just so the lines work out for me a bit better. Now we're told the frictional force is equal to the weight, and the frictional force acts down the track. So that I'm going to call F, and F equals mg. And that's a bit strange. It's a hard question, this. That's a bit strange because it being equal to the weight means it must be greater than the normal reaction force, which is a bit unusual. You wouldn't normally have the frictional force being greater than the normal reaction force. So we've got a normal reaction force, which I'll call N, and N acts at 90 degrees to the surface. It's a normal reaction force to the surface, and that will counteract the component of weight going down into the surface. So that's the weight going into the surface, mg. So the bit I was trying to explain is how do we resolve these components? Well, if I extend that just with a dotted line, what I'm interested in is what component of mg counteracts n. So I can work out n by the component, and I work to this line using this angle. Now, it's a right angled triangle. So I'm looking at this triangle now, right angle triangle, 20 degrees, 90 degrees, that gives me 110. So this angle in here must be 180 take away 110, because it's got to add up. So 20 plus 90, I've got to be 180 in total, so that's got to be 70 degrees. Now if that's 70 degrees, the angle between the frictional force, or the surface, and the normal line has to be 90 degrees in total. So this has to be 20 degrees. So the angle of the normal to the weight is 20 degrees. So generally, if you practice this a lot, you'll get used to the idea that if that's true, then N equals mg, and it's cosine, because it's going with the angle, cosine 20. So now we've got F and N written in those terms. Okay, next bit is we know it's moving in a circle, and the plane of the circle, and if this red pen works, I'll be thrilled. The plane of the circle is here. Oh, it does. Hooray. I'm thrilled. So that's the plane of the circle it's moving in. And we must have a resultant force because it's moving in a circle. And that resultant force has to be exactly in this direction, and it has to be equal to mv squared over r. And we're asked to find v. So the resultant force is mv squared over r, and we now need to look at these three forces to see if they contribute to the resultant force. Now, the weight of the car cannot contribute to the resultant force because it's at 90 degrees to it. So I only need to consider N and F. Now, N and F are at 90 degrees to each other, and I need to work out the angle between N and F and this horizontal plane. So F's angle to the horizontal plane is 20. That's a standard GCSE Z angle. If that's 20, this is 90, this one has to be 70. Oh, and I've written 90. Try again, 70. So, again, using cosine, N cos 70 is the component of N in the direction in the horizontal plane. F cos 20 is the component of F in that plane. So, that means that the resultant force mv squared over r must equal N cos 70 plus F. F cos 20. But we already know some other information here, and this is where this gets messy and why it's a bit of a weird and hard question. So we get mg cos 20 cos 70, we just multiply them together, yeah? Then mg cos 20. Now, mv squared over r, the m's all cancel, so the MasterCard doesn't matter. Okay, so then v squared is g cos 20 cos 30, sorry, cos 20 cos 70 plus g cos 20 all multiplied by r. So we can stick that rather unusual looking thing into our calculators. So cos 20 times, just checking them in degrees, times cos 70 times 10. I'm going to go with 10 because I just want to get this done. So 3.2139 and other stuff plus cos 20 times 10 is 9.39, 9.3969, some other stuff. All multiplied by, it was 44 meters. Okay, so v squared equals, don't forget the v squared, 3.213 times 44, and we get 554.87, but that's v squared. So square root that, and we get that v equals about 23.6 meters per second. Not an easy question.